Hey guys, just me. Check out all my fancy mathematicians out there. Hope you guys are excited for today's lesson. So I hope you are ready to go with a pen and paper and a notepad and everything to take some notes. We're going to start right off with number 1. Ready, set, haha, just kidding, April Fools. Alright, so let's get to this. Oh man, what a fun day. I hope you guys play fun and safe tricks on your family. It is a day to have some fun, and maybe we need a little bit of fun in our lives, okay? Alright, so let me get refocused. So we are doing lesson 3 today. Before we get started on that, let's get some review and talk about what you guys have done the past couple of days. All right, so let's see here. So today is April Fool's Day, April 1st. It's Wednesday. It's also Miss Cumberbatch's birthday, so find her, say happy birthday to her. I'm sure she'll love it, but don't tell her I sent you because then she'll yell at me. So it's lesson 3, and we're still dealing with the same problem. So on Monday, you guys translated systems of equations, defining the variable, then translating it, right? Yesterday, we continued to translate, but then we looped in our knowledge about linear equations. And so then today, what we're going to do is we're going to go still based off of system of equations, use all of the knowledge that we worked with yesterday about translating equations, and now we're going to talk about the number of solutions a system can have. So we've practiced this a bunch where we simplified equations down into a form where we got x equals a, like x equals a number, and then we simplified them down and we got 2 different things on both sides, and we would draw that sad face because a does not equal b and it never will. And then we have a equals a, and that is always going to be true, so that gives us infinite number of solutions. And so when we get x equals a, that means we have 1 solution. When we get a equals b, when we have 2 different numbers on both sides, that means no solution. And a equals a, infinite solutions. So I would take a second on your notepad, maybe hit pause real quick, and I would jot down these notes. And you can combine it all into one table like that. So 1 solution looks like x equals a. No solution equals a. It would look like a equals b. An infinite solution would be a equals a, where it's the same thing on both sides, meaning it's always going to be equal. So hit pause and jot these notes down. Oh, and welcome back, if you paused. So just to preview our CFS for today before I hit play over on my work on this side. So today in your CFS, you're going to have to determine the number of solutions by simplifying the equations. So simplifying both sides all the way down until you get one of these forms. And then you're going to determine, or some of the questions might be like, hey, is this a solution? And if they are asking you if it's a solution or not, then you're substituting in that value. Because if it is a solution, we know that that satisfies the equation. And then when you are asked to explain, because I know that some of you guys are losing points because you're not completing your explanations. So in your explanation, please make sure to include what form did it simplify to, and then what did that mean for the number of solutions. So, oh, this equation simplified down to x equals a. Therefore, this solution has only 1 solution, and that solution is a. So you are going to have to make sure that you... Stanley's having a hissy fit. He wants to get back on the camera. All right, so you want to make sure your explanations include each of those different forms and then how many solutions that it has. So let's take a look at number 1 and what we're working with. So if you don't have a notebook ready, maybe hit pause again, get that notebook ready, because you should take notes for number 1. So when you get to the assignment, you can quickly put it in. So this is question 1. And the question is asking, given that 2x plus 7 equals 27, of course, let's get in there with the color coding, 3x plus 1 equals 28, then can we write the statement 2x plus 7 equals 3x plus 1? And so I want us to think about this. Let's rewrite the equations so we can see them a little bit better. So if we write them down below, we have 2x plus 7 equals 27. And then right under that, I'm going to write the second equation, 3x plus 1 equals 28. And I'm going to ignore everything on the left-hand side, and I'm just going to highlight the 27 and the 28. Because essentially what they're asking us is, does 27 equal 28? And that absolutely is not true. 27 does not equal 28, and it'll never equal 28. And we can set that to equal to each other because we know that 2x plus 7 equals 27. We know that 3x plus 1 equals 28 because they told us. No other reason other than because they told us. And so if this equals 27 and this equals 28, then I can substitute those two in with 27 and 28. And when you look at it that way, it's obvious. 27 is never going to equal 28. So if you're wondering how many solutions this system can have, it's no, because they're never ever going to equal each other. That's where we would do the big sad face. Like they're never ever going to be true, so sad face. So if I were to be writing this as an explanation, I would write in that place. There are no solutions. I apologize. The question was, can we write it like that? So, no, the equation 2x plus 7 equals 3x plus 1 is not true because 27 does not equal 28. This is the form of A equals B, meaning there are no solutions. All right, so that would be an example of how your response would look to a problem today. If you notice, I referred to the form that it simplified to, and I mentioned how many solutions there are because of this form. So we know that A and B are never going to equal. So if you ever get the form of A equals B, there are no solutions. So today, in the problems, you are going to determine the number of solutions by simplifying. So you're going to simplify both sides of the equation all the way down to either get x equals A equals B, or A equals A. Then from there, you can determine how many solutions there are, and then you'll be able to answer the question. So make sure you read the question, because there are questions that ask you to substitute values in, and they ask, oh, is this a solution to the equation? And you would know it's a solution because once you substitute it in, it satisfies the equation. You guys are super prepared for today's lesson. Keep all of this stuff in mind. Remember, you can always pause my video and you can jot down a couple of notes for when we get to the practice session. And oh, please make sure you join us for the tutoring sessions. We've been having a lot of fun in those sessions. It's been really great to hang out with our classmates and be back together again. So if you see a meeting ID or a request to join a session, please do. And can't wait to work with you guys. So have a wonderful day growing that math brain, and I will catch back with you later, whatever that means. Bye, you guys.